award winner tonight is Thordon Bearings from Ontario, Canada. They have a great solution using seawater instead of carbon-based lubricants in propeller shafts. And our thanks for the referral goes to Peter Cairns for this referral, bringing it to Ocean Exchange. The presenter for tonight's discussion is Craig Carter, who's the Director of Marketing and Customer Service for Thordon Bearings. So please help me welcome Craig.
Oh, it is bright up here. First of all, I'd just say that I am honored to be here in this wonderful city of Savannah. It's a beautiful city. I was out walking around this morning. And also a big thank you to the Ocean Exchange for selecting our product and giving me the opportunity to present to you a sustainable solution to eliminate the risk of discharges from commercial ships to our oceans and seas. So Thordon Bearings is a manufacturing company. We're based just outside of Toronto, Canada, and we manufacture non-metallic bearings. So it's not ball bearings, it's not the typical bearings that you would think about. We export 90% of our products around the world, and the shipping is global. We have 85 distributors around the world, and they support typically the commercial ship owners that use our products. These are the bearings that we manufacture in the picture shown here. And most of these polymer bearings are used in the marine industry, propeller shaft bearings and rudder bearings, but we're also used in hydroelectric plants, offshore oil vessels, wave and tidal energy, clean power generation, water treatment plants, vertical turbine pumps, and many other industrial applications. We've been producing these non-metallic bearings now for over 35 years, creating a positive impact around the world's rivers, seas, and oceans. These bearings are delivering long life without the use of oil and grease. Just a little about myself. I was born and raised in eastern Canada on the island of Newfoundland. And that's where you can see our provincial bird, the Atlantic puffin, all along the coastal waters. According to Environment Canada, chronic oil pollution coming from ships traveling off the east coast causes hundreds of thousands of seabirds to die every year. In the late 1990s, an estimated 300,000 seabirds were killed every year off Newfoundland's coast. See, the problem is oil doesn't mix with water, and it gets readily absorbed into the bird's feathers. And when that happens, it decreases the bird's insulation, as well as their waterproofing and buoyancy. This inevitably leads to starvation or hypothermia. So just a little drop of oil can actually cause the death of birds in our oceans and seas. So as you can see by this map, shipping is certainly a global industry. Most of the ships, of course, from China over to America, as well as from Europe to North America as well. I'm from the island where the circle is the big island on the east coast of Canada. So that's where a lot of the seabirds live as well. So most of the goods that we use every day are typically delivered by ships. Container ships, actually a big one went by the river today, Maersk container ship. There's ferries, there's bulk carriers, car carriers, and oil tankers. And most of the world's commercial fleet, they use what's called an oil lubricated propeller shaft bearing system. So let me explain a little bit more about what that is. Well, this is what a ship looks like. This is called the aft end of the ship, and it's out of the water. It's in a dry dock, of course. And this particular ship has two propellers. A lot of ships have one propeller. The propellers, of course, are connected to a shaft, and the shaft is connected to the engine. The engine turns the shaft, which turns the propellers. And there's oil in there that lubricates the shaft and the bearings. So this is the part of the ship where the seawater interfaces with the ship. The yellow arrow is pointing to a propeller shaft seal, and that's the important part of an oil lubricated system. The purpose of the seal is to keep the mineral oil from leaking out and the seawater from leaking into the ship and contaminating the oil. The seawater ingress can cause serious damage to the metal bearings, and of course, if oil leaks out, it can cause serious damage to the environment. Here's a little different schematic that shows a different view. Basically, you have the propeller shaft and a long shaft, and there's two bearings, a forward and aft bearing, and as well as two seals. And there's one aft seal and a forward seal. Of course, the aft seal prevents oil from leaking out, water from coming in, and the forward seal prevents oil from leaking into the engine room. And all this machinery operates below the waterline of the ship. The other thing I should just mention, there's typically, I think there's 400 to 800 US gallons of oil in this particular stern tube system. So seals have been around for over 60 years, but they're not perfect. When they leak oil, there are serious consequences for the ship owner, especially in the last few years, as new regulations and tougher enforcement means that any oil leakage may bring fines and jail time to the ship owner. So is there a risk? Well, there's operational oil discharges, which is the normal wear and tear of those seals, as well as accidental oil discharges. It's really hard to quantify how much oil leaks from a ship, as the ship's propulsion system is typically below the waterline. And of course, the ship is constantly moving as well. However, a research paper was written by a New York-based consulting firm and presented at the Arctic Marine and Offshore Marine Oil Spill Program conference in 2010. And this was the first authoritative study done on commercial ship propeller shaft lubricating oil operational discharges. The study was done on port oil discharges from ships, but the author estimates the amount of discharges at sea to be around 34 to 64 million US gallons of oil annually. And just to put that into perspective, it would be equivalent to 137 Exxon Valdez oil spills since the disaster in 1989. So how does the oil leak out? A lot of times it's simply a fishing net or rope. It wraps around the shaft and damages the seal, and the oil leaks out. Or sometimes the seals themselves wear, or the propeller can hit the bottom of the ocean floor, and if it's operating in Arctic environments, it can hit the ice, and that causes increased oil to leak out. The issue is that ships do not operate in a perfect world. Even if you have rope cutters to try and cut away the rope from collecting on a rotating shaft, it's amazing how often something as simple as a monofilament ship fishing line can damage the shaft seal and allow accidental oil leakage. And that's a major headache for today's ship owners, and of course harmful to the environment. And that's one that must be reported to the Coast Guard, the US Coast Guard or Canadian Coast Guard immediately. The good thing is that new shipping regulations come into effect in a few months. This means that ships will need to use an environmentally acceptable lubricant, which can be biodegradable lubricants or seawater, used to lubricate the propeller shafts. And one of the things the U.S. Environmental Protection Agency is stating in these new laws is that they're recommending that ship owners use seawater, and that works really well with our bearings. So as you can see, commercial ship oil discharges below the waterline are a serious issue. But can they be eliminated from our ocean seas completely? Yes, they can. So prior to the 1950s, all ships used to use water lubricated propeller shaft bearings. Seawater was used as the lubricant, and the bearings they used at that time was actually made from wood. It was called lignum vitae, and that was used to support the shaft. But the problem with that issue, or with that solution back then, is that it was unreliable. No one knew when the bearings were going to wear out, and sometimes they had to change the bearings when they crossed the Atlantic Ocean. However, navies and coast guards, they still use seawater lubricated propeller shaft bearings. Basically, they use it because if they take a hit, and if they were using an oil system and the oil leaked out, they would be stranded. It would be catastrophic. However, with water lubricated bearings, they don't have to worry about that seal keeping the oil in because it's lubricated with seawater. So both the US Navy and Canadian Navy, nuclear submarines, the Seawolf submarines, for example, use seawater lubricated bearings manufactured by our company. So here's a little video that demonstrates how the system works. We basically have seawater coming in through the sea chest of the ship, and we actually clean the seawater and make sure that there's no abrasives in the water. And because we now have clean water, the bearings will last longer. So we pump the seawater through the stern tube of the ship, and then basically there's no seal on the end, and the seawater just goes back into the ocean. One of the important things about the system, however, is that it's seawater. So what that means is highly corrosive. So we have to ensure that the stern tube is painted with anti-corrosion paint, and the propeller shaft needs to be coated with an anti-corrosion coating that's flexible as well, because you all know when a ship is in the water, the shaft does flex. But a water lubricated propeller shaft bearing system is actually technically equivalent to an oil system, and it fits in the same space as well. So these are the bearings that we manufacture. They're a non-metallic bearing, and it's called an elastomeric polymer. It's a proprietary ingredient, and they operate without the use of oil. We call this orange bearing a compact bearing, and they're used globally in navies, coast guards, and commercial ships. So this is not new technology. Currently, we have over 600 commercial ships fitted with Seawater lubricated shaft bearings, and we're seeing the number of inquiries grow for this zero pollution solution every week. I love that, a zero pollution solution. It has a good ring to it, doesn't it? But as you can see, there's several users that are American companies, Canadian, Chinese. So as you know, cruise ships travel to environmentally sensitive areas, so any oil leakage would be a real concern. One of the first ships that we actually installed Seawater lubricated bearings was the Grand Princess, owned by Princess Cruises at the time in 1998. Actually, Princess got bought out by Carnival Corporation based in Miami, and they've actually now have 16 cruise ships running with this system, and there's 2 more on order. And the projected life of this bearing is equivalent to a metal bearing, so it's going to be around 15 to 20 years. Princess Cruises knows that it works, and another cruise company in Miami, Disney Cruise Lines, they're using the same system as well. So let's take a look at the pros and cons of a Seawater lubricated system. Commercial ships have been using this new design since the late 1990s with very few issues. It can save the ship owner money because there's no seal maintenance costs. There's no seal used at the back end or the aft end of the ship. There's no oil storage. You don't have to dispose of the oil. You don't have any risk of pollution fines. And you don't have to do any emergency seal repairs if you're using our system. So as I mentioned earlier, the negative part is that you do have to protect now the propeller shaft and the stern tube of the ship with corrosion protection. And that may increase the upfront cost. However, what we're looking at now for like a standard size bulk carrier or oil tanker, payback period about 4 years. So it's certainly improved from the past. And of course, we already have 600 commercial ship owners that use this system. So today, new zero pollution Thordon bearing systems operate interchangeably in the same space as an oil lubricated system. And these Seawater systems have been widely used around the world in all parts. And the usage eliminates any source of oil pollution having a positive impact on their seas and oceans. I think the future will likely bring change to the shipping industry, and we're ready to meet it. And those seabirds I mentioned earlier, if you ever go to visit Newfoundland, they'll be there, and you can take your pretty picture as well. So, thank you very much for your time.
Very good. And questions for our final speaker tonight?
Hey, I'm sorry, I don't want to dominate this, but I have a question. Maybe
Witness protection guy.
someone else?
Come on up. Go ahead, Jim.
What's the application of this to offshore drilling and pipelines? You already have ConocoPhillips tankers for the shaft in the offshore drilling.
Actually, in offshore, we're on FPSOs, so we do the turret bearings on FPSOs.
That's Seawater lubricated?
Yes.
And they're using those now?
Yes, they are.
So what would that impact would that have, like on the BP oil spill?
Actually, none, because the FPSO is a floating production, storage, and offloading ship. So when the oil comes up from the system, the turret supports the pipes coming up from the bottom of the ocean, and they're lubricated with the seawater because the pipes, they use dynamic positioning to keep the vessel in one spot, and basically it's lubricated with seawater, and there's no oil involved there.
But the drilling shafts could not have the same kind of...
No,
okay,
no,
thank you.
That's one technology that we're not involved in.
Was there another question? Oh, there was a hand one up. Please.
Just a very simple question. Are the saltwater lubricated bearings easily retrofittable on the oil ones on current ships?
Yep. We've actually just converted 5 large oil tankers at Seawater shipyard in Singapore. And they're owned by ConocoPhillips. They've had some seal problems, and now they're running the Seawater lubricated bearings.
One more round of applause. Thank you. Oh, yeah, please. Bear with us one more second. I've got some important parting comments for you about tomorrow morning. Got a picture taken here. Congratulations.